our last lecture, we have learned how to write our first program, that is the Hello World program in Python. We have seen how we can install Python in our local machine. We have also seen that if we do not want to install Python in our local machine, how can we use Python in cloud? Now in this lecture, we'll go slightly deeper into Python. We'll discuss about different data types in Python. In last lecture, we have seen only string data type. In this lecture, we'll see few more data types and some mathematical operations and data structure with Python. Then we'll particularly look at this list type of data structure and range function, which will be an useful function for us. For a program to flow properly, we need certain tools such as if block, while, or for loops. We'll discuss that in this lecture. This is to remind you that we are only talking about minimalistic features of Python that are necessary for scientific computing. Python has numerous data types, data structure, mathematical functions. We are not going to discuss all of them. I have selected only a handful, and let us see what are they. In Python data type, one important data is string, and you have already seen that in our last lecture. You have already seen integer. In an example, I have shown you integer, and integer numbers are of course very important in all applications of science and engineering, so we'll use it quite often. Then we have real number, or in computer language, what we call these are floating point numbers or float. After that, we have complex number. We know that certain quantities in science and engineering are better expressed in terms of complex number. So Python has an inbuilt data type for that, that is the complex data type. These four are the most important for us in scientific computing. And other than that, there are several other data types, for example, Boolean, which will take only true or false, 1 or 0. That is how it is. And several others, but we will probably don't need them so much in scientific computing or especially in this course. Then this data itself sometimes not very useful unless we put them under a structure. So Python has several important data structures, and we'll see one of them in this lecture. One structure is of course array. Array doesn't come in native Python. We have to include this NumPy package, and later on I'll show you that how to do so, because array is the most important data structure in scientific computing. We have to learn it. To generate array, of course, we need a Python native data structure, that is list, which will be a list of several data, and we'll see that how it is. Somewhat similar to list are tuple, which is again a list of several data, but there are fundamental differences between list and tuple and dictionary, and they are useful in their own way. But in scientific programming, most important are arrays, and somewhat important is list. So in this lecture, I'll talk only about list, and array we'll use from NumPy, and we'll talk about NumPy later on, not in this lecture. Once we have data, we always do certain arithmetic operation in our calculation, such as addition, subtraction, etc. So in native Python, we have this addition as a plus sign. If you have gone through the exercise from our previous lecture, you must have tried addition over string and learned something about it. Similarly, there is subtraction, multiplication, and exponentiation. So if we want to have power of something, for example, a to the power b, this is the exponentiation. Then I have a real division. That means the actual division, like a divided by b. When I divide a by b, then I can have an integer division as well. So that gives me A, B like this. So for instance, if I divide 3 by 5, I get a real division of 6, but 3 by 5, if I divide, then it is 0, 3 and 2. So my integer division will give me 0. The remainder in this case will be 2. So that will come through this remainder. So if I divide 5 by 3, that would be 2 as remainder, but integer division will give me 0. All of them are very important in actual mathematical calculation, and we will encounter that very often in scientific programming. Then we have more complex mathematical operation, and such mathematical operations we cannot do in native Python. We have to import something. So let's get familiar with this particular keyword import. When we'll use NumPy later on, we'll have to import NumPy, but even before that, we have to import math here for certain mathematical operation. This mathematical operations such as sin x or sin inverse x, they are not natively inbuilt in Python. So we have to import this math package, and we have to write this math.sin x. So at the beginning of the program, we have to write this statement import math, and then we have to write math.sin x to get the value of sin x, or math.asin x to get the value of sin inverse x, math.log x that will give me natural logarithm of f. Similarly, erfx will give us error function of x, etc. There are a long list of mathematical functions that are available in math package, and we will encounter many of them in our usual scientific computing. So what are the most important packages in scientific computing then? First, of course, is the math package. And then you will see, not in this lecture, but subsequently you will see that NumPy package will be very handy for us in mathematical calculation. Some of the complex mathematical program that we will write by ourselves, later on you will learn that if we use this package SciPy or Scientific Python, then all those complex mathematical calculations can be accomplished very easily. So these are the packages. Math and NumPy are most important, and sometimes we may use SciPy in bigger and complex programs. These are most important packages in scientific computing. In scientific computing, sometimes the end results are certain numbers, but sometimes the end results are plots. So Python has this very powerful matplotlib package, which we will use for plotting the results, and we will see next. Few lectures that how to use this matplotlib package. Now we come to one of this data structure, that is list. This is a mutable data structure. By mutable, we mean that the structure may have many data, but we can change one data at a time. That is possible. The structure can hold different types of objects. So for instance, let us say A contains 1, this is an integer, then there is hello world, this is a string, then there is a complex number 1 plus 2j, j here means root over minus 1, 3.5 is a real number. If I now try to print A, this A will give me within third bracket 1 hello world, 1 plus 2j, 3.5, and this type of A is a list. So in this list, I have integer, real, complex, string together as a block. I can take one of this item and change it if I wish. In last lecture, we have already talked about function that takes one or more inputs and usually give at least one, sometimes more output. And we have seen in last lecture inbuilt function of print. Functions can be inbuilt, functions can be user defined as well. We can make our own function, and we have to obviously make our own function in scientific computing very often. You have seen this print function where this input goes inside this first bracket, and then whatever the input is there, it writes it on the screen. Now let us see another function. It will be very useful for us. What we call is range function. So we write range and the input goes here. Input is usually integer. It doesn't mean that it cannot be a real number. It can be, but preferably it would be integer, at least 1, and it will give us a list, and that list has something specific. We call it that iterable object. Sometimes we will get that iterable object, and that will help us a lot in writing our program in scientific computing. So let us see what it is. So for example, I give an integer of 5. It will generate a list. That list will contain 0, 1, 2, 3, 4. So as I give 5, it starts from 0, and then with the increment 1, it goes up to 4. Once it hits 5, the function stops there. So it will not write 5, it will write only up to 4. Or if I give an integer n here, range will start from 0, 1, etc. It will stop at n minus 1. So the number n is giving a cue where to stop, but this list does not include n. This is very important to remember. If I give range 1, 5, then it will start from 1. So this 1 I am giving, the default start is 0, but now it is starting from 1, and it will go once again up to 4. It will stop there. If I give 1, 5, 2, it will again start from 1. It will stop at 5 minus 1, but the increment will be 2. So first will be 1, then second will be 3. 3 plus 2 is 5. It cannot write 5. It has to stop at 5. So this list contains only 1 and 3. The list can also go in other direction. For example, I can write 5, 1, minus 2. So then the list will start from 5 and it will go up to 1, but not including 1. So 5 minus 2 is 3. So it will start from 5. Next element is 3. Next 3 minus 2 is 1, but this list cannot include 1. So the list will have only 2 elements, 5 and 3. So such numbers, when we generate, we call them iterable objects, and these iterable objects have a very important role to play in Python loops, which we'll see later. There are other kind of operators in Python which we call comparison operator, which will compare two numbers. I have already give you one example in last lecture. So here this is an equal operator. It equals, so if I write A and B here, then this operator checks that if A is equal to B. And then it takes a decision. If A equals B, then it is true. If A not equals B, it is false. Similarly, I have this not equal to, and not equal to I write in Python as this exclamation type marks, and equal to. Greater than and less than are very similar sign, just like in simple mathematics. And we have this greater than equal to and less than equal to sign here. These comparison operators will also be very important for us, that we will see shortly. Now we come to the first item of what we call is the control flow in Python. When we will write a program, we have to allow the program to go in certain way. So to steer the program in our preferred way, we use certain cues, and they are our control flow. First of this is if block. So if there is some condition, these conditions, most of the time you will see that they will come from this comparison operator. If some condition is true, then the program will do something. But if it is not true, it will not do that something, it will skip. And then again, there is another condition here, it will come here. So this is else. Else essentially means else if. So if this condition is not satisfied, it will hit this else if, and it will see there will be some other condition. Usually it will come in terms of this comparison operators like this, and some statement my program will execute. There may be several else here, and when if is not satisfied, none of these else are satisfied, nothing here are satisfied, then my program will enter in else, and whatever is written here to execute within that else, program will execute that. Similar to this if block, there are certain loops in Python program. Two important loops are, one is this while loop and another one is this for loop. They are very important to control our program. So let us see how they work. While loop comes with certain condition, and this condition usually come from these comparison operators. If these conditions are satisfied, it will do something. Now, what is the difference between if block and while loop? Well, the difference is that until these conditions are not satisfied, the while loop will continue to do something, whatever we have asked it to do. So this is a loop. The program will run in this loop here, and it will continue to do whatever we are asking it to do unless this condition is not satisfied. Similar to this while loop, we have this for loop. In for loop, we are not giving conditions, rather we are giving certain iterable objects like what we are generating using the range function. And when certain item is in iterable objects, the for loop will continue to do something, whatever we are asking it to do. Once this iterable object list, it has completely used up, then the for loop will stop. In most programming, we will have this while, for loop or if statement, very similar to Python. And in most programming, when we write this if or while or for, we will have an indentation like this. Like this, we will have an indentation. Indentation in most language are only for aesthetic purpose, for ease of reading the program. But in Python, as we'll see later, these indentations are absolutely necessary. Otherwise, Python will give us an error. Just like the indentation, the colons, as you see here, these colons are also necessary in Python, which is unlike many other programming languages. Similarly, these blocks and loops, they will close when the indentation is removed, which is unlike most other programming languages. In most languages, this block has to be closed properly with a closing statement, but here there is no closing statement. So for example, I am in while loop and my program is doing something. When it exhausts this comparison, then it will come here and see what I have written here, what statement I have written here, and it will start executing it. As I come from here to here, my program assumes that my loop is closed. I don't have to write here certain statement, for example, end while, which are common in other programming languages. We can now go to our Jupyter lab and try some of these things that we have learned now. So here we are in our Jupyter lab, and let us say we first check the math function, and in math function here we write, let us say that to invoke math function, of course, we have to first import it. So import math, and then we write a equals math dot sign. Within sign we write 0.5 multiplied by math dot pi. So that means this a is now sine pi by 2. So let us see that if it is like that indeed. So print a and now shift and enter. So you can see that it is giving 1.0. What is the value of sine pi by 2? Now, if you do not want to write this math all the time, then what you can do is like this. You can write this import math as something smaller. So for example, empty, and then you can write the same thing, that is a equals empty dot sign 0.5 multiplied by empty dot pi, print a, and you can see that this is still 1.0. So empty is now a short form of math. For the least data type, you can write this a equals within third bracket 1 hello world complex 1 to 3.5, and then again you can print a, shift enter. You can see that it is giving us within third bracket these 4 elements in my list. What is the type of a? You can see that this is a list type. Similarly, you can check the range function and for loop. So for instance, for I in range 5, I have to give an indentation here, print I. Now this will not run because I didn't use the colon here, so I have to give a colon, and now it should run. And see that it has given us 0, 1, 2, 3, 4. Similarly, you can check the other examples we are giving in lectures. So for example, for I in range 5, 10, print I, and you can see that it starts from 5 and it stops at 9. So this iterable object that the range is creating, my for loop is iterating over those objects. It is printing I. As soon as this object list is completely used up, my for loop is stopping there. So now to summarize, in this lecture, we have learned few data types. One data structure really we talked about, that is the list data structure. Some simple mathematical operations. An important function, that is the range function, we have seen. And we have learned very important control flow items, which are if block, while, and for loop. All of them will be very important for us in this course, and in general they are important for scientific computing. For further reading, I'll again suggest you to go to this Python wiki and get more examples from there. You can also use this Python 3 standard library by Hellman. For your exercise, you will see that Python has several other very useful functions. For example, one is this reverse range. You use this function and see that what it does. Similarly, if I write this range 6, then it will create a list from 0 and it will stop at 5. It will not include 6. But then if I write range 6 within third bracket 2 to 5, what does it do? Check it out and let me know what you think, that what does it do. That's all for this lecture. I'll see you in next session.